Right. So in this video, we'll continue with this tutorial sheet, and question here 13 says express into recurring decimal fractions. So into recurring decimal fractions. Are you guys allowed to use versus calculators in your math?
No, we are not.
You're not? Okay, all right. So how do you then express this one? Let's begin. So remember how to do these decimals the way you were doing it even in secondary school. So you have 1 over, okay, so you have 1 over 6. So you see that this here, how are you going to get it into recurring decimal? So first of all, this here cannot divide, so that's why you write your 0 like that, then you add another 0 there, isn't it? Then when you divide there, you have 6 dividing into 10, and 6 divides into 10 how many times? That goes into 10 once, and it leaves a remainder. So it leaves a remainder, and we're saying that remainder is just, so this here is going to be 1 like this. Then now the remainder that you have 4 as a what? As a remainder. They have 4 as a remainder. Then after you get 4, again here you have to what? Replace you say your value there. You put an 6 into 4. Of course we cannot divide that, so we put another 0 here, and we divide it into 4 into 40. So 6 into 40, it enters 6 times. So it enters 6 times. What you do from here, you get 6. Then how? What's the remainder there? You get a remainder, since 6 into 40 enters 6 times. So we understand that that is because of the 36. Then 40 minus 36 gives us what? Gives us 4. Then you have 4, and you have recurring 4s that are going to what? That are going to continue. So recurring 4s like that are going to continue. So when the 4 reoccurs like that, again you put a 0 to that next what? To that next 40. Then you divide, it will give you another 6 like that. So it continues to go. So from here you see to be 6, 6, 6, 6 like that. So now you can write this as 0.16. So you can even write a bar there, indicating that this part is the repeating part, or you can write as 0.1. Then you have 6 cos 6, then like that writing. So somebody will know that what is recurring there are the 6s. Okay, so let's do the next one. Next one, you have 7 over 11. So you do the same step. So divide that there, you get 0 first of all. Then you have 70 there. So 70, then you divide 70. I mean, you divide 11 into 70. So when we divide 11 into 70, how many times does it go there? It goes there 6 times. So we know that the number close to where it divides there, where 11 goes without leaving a remainder, is 66. So into 66, it goes 6 times. So then we have 70 minus 66. What does this give us? So 70 minus 66 is just going to give us 4. So meaning this here leaves a remainder of 4. So after leaving a remainder of 4, again 11 into there, we cannot divide that. So we add another 1 6 there. So which we have 40. Then for 40, again we see what value is going to be there. Divide the 11 into 4. The closest value is 33, and it enters how many times into 33? 11 goes into 33 3 times. So now that means that you're going to have 3 here. Then what's the remainder? So the remainder in the 33, you have that your remainder there is going to be, that's going to be, so the closest 33 minus 40 is what you're doing. 33, oh, Yeah, 40, I mean 40 minus 33. Then it gives you a 70 again. It gives you a 7, I mean. 7, then you get a 70 again. Then what did you divide there? So to give you a 3 again. I mean a 6 again. Then gives you the same remainder of 4. Then again it continues 4, then you get 3 there. Then so that means you continue dividing like that, and you just have that your repeating units there is the same 6363. So it continues as 6363 like that. So you can write this as 0.63, then you indicate your bar there. Okay, now let's do the other one. So how do we do the other one now? The other one, you have 3, then you have 2 over 9. So now, after getting this here, how are you going to work out this? Remember, this is a mixed fraction. So you multiply that 9. So you multiply the 9 by the 3, it gives you 27. Then you add by the 2 there. So 27, then you add plus your 2 there, which gives you 29. Then you have 29 over, of course, the 9 there is what you're going to get. So you have 29 divided by the 9, which is down there. So now how are you going to do this? So divide this one. Here it can actually go, or it can divide the same way which we had, which is just 3 like this. In fact, if you desired, what you'd have just done is not even going this far. So you look at your 3 here. So you already know that this 3 here is a whole number, which like it's the number of times that this 9 has divided. So you just bring your 3 here separately, then you put a dot there. Then now you divide your 2. So you divide 2 into 9 like this. So when you do this, so let's keep our 3 like just there. Then here we divide this. What do we get? We get 0. Then we add a 0 there. Dot. Then into 9 divided into 20. It's going to give, then as there are 2 times, then you have a remainder of 2. Then again, so you continue to get what? 2's, 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 2's like that. So you add this 0.2222 with this 3 which is there. So you just get that when you add those 2, you're going to get 3.22 like that. So you can write this as 3.2 with a bar like that. Or if you wanted, you'd have done this where we did the 29. We brought it back just to single fraction. Then we say 29 divided by 9. Then that there is going to give you, okay, so that there then just gives you 3. Then now, what is the remainder that you get when you divide there? The remainder 2. Then 2 here, it can, we cannot divide, so we add a 0. Then that gives us 20, gives us 2. Then 2 like that. You continue getting remainders of what? Of 2's. So this goes up to infinity like that. And of course, to give you the same thing which we had like 3.2 with a bar there. Okay, so that's how you do this one. Now the next one. Remember, feel free to ask. This is the time to be clear on how to do this. So 3, for the other one, we do the same. So we get 3, separate 3 there, then just let's work out our 8 over 5 there. So what are we going to get here? So we get that this will be equal to 0 like this. Then you add a 0 there. Then you have 15. You have 8 dividing into 15. So when you divide into 15, it enters how many times? 5 times. 5, 8 into 15 goes 5 times. Then what's the remainder? So the closest number there, that is, should be 75. 75, yes. So you have 75 divided by 15 gives us 5. Yeah. So 75. So 80 minus 75. This is going to give you what? 5. So which means here we get a remainder of 5. If 15 into us is, it cannot divide. So we had a 0 here. Gives us 50. So 15 into 50. So 15 you divided by, I mean 50 divided by 15, you get what? You get 3. So now check again, what's the closest number which you have there? Should be our closest number is 45. Okay, yeah, is 45. So 45 minus what? 50 there. So into 45, 15 goes 3 times, which is a 3 there. Then now that will be remainder what? Remainder 5. So it gives you a remainder of 5. So then again you divide, and that here is just going to continue to give you 3, 3, 3, and up to infinity like that. So what we just have when we add this part here to the 3, we just get 3.5333 like that. It continues to go, which is just equal to 3.53 the bar there. So that's how you are able to solve this question, unless there's anyone with a question on this part, but that's how we get this. Okay, since there are no questions, we move on to this second part which follows, and it says express each of the following in the form A over B, where A and B are relatively prime and B is not equal to 0. So which means A and B should be co-prime. That means they do not have any common denominator. Is that a question? Okay.
I have a question for the expression into repeating decimal fraction.
Yes.
What if you multiply 15 times 3, then plus 8 over 15 you divide it? Are you going to get the same answer?
Yes, you're going to get the same answer. So let's multiply. When you multiply this 3 by 15, you get that is going to be 45, right? So then you have 45 plus 8, that gives you 53. So 53 is being divided by what? By 15 there is what we're dividing. So now you can check this. We know quickly from the way we were just finding. So divide the 53 by 15 dividing into there. How many times does it go into 53? So here we divide, we'll get, this is going to give us 3, goes in 3 times. What's the remainder? What's the remainder there? So you do 53 minus 45. It gives you a remainder of what? Of 8. The remainder of 8. We know 15 into this 8, it cannot divide. So we put a decimal place there. So then we add a 0 here. Then we divide now this 15, dividing into that 8, that gives us a 5. Then from 5, remainder what? 5. Then here we divide 15 into 5, we can, so we put a 0, gives us 50. Then into 50, you'll be getting 3. It will be just giving you remainders of 5. So it will continue 3, 3, all the way like that up to infinity. So that's how you get that.
All right, thank you.
Sure, you're welcome. All right, so now let's continue with the part that follows. You have this here is just going to be, okay, so they're telling you to express each of the following in the form A over B, where these are relative or they are co-prime. So what you do is, first of all, you always have to check when you're dealing with this, you want to make sure that you have a case where your decimal point is just right before the recurring values. So in our case 1, we have 0.14 with a bar like this. So with this one, what this means is just 0.444 like that up to infinity. So now they want us to express it as a what? As a irreducible fraction. So now how are we going to do that? So what we can say here is we can let this, so our decimal place already is just before our recurring value. So meaning we don't have to multiply this by either 10 or 100 or so, as you will see in the next ones, but we just go direct and say let x or any variable be equal to 0.4 with the bar. Then what you want to do next is you want to move this decimal point such that it moves 1 unit. So you look from here, you move it such that it moves 1 unit like that. It should be here. Then this side, meaning it will continue going like that. So why I want this to move is such that this part with the bar should subtract with this part here where I've said let x be equal to that. So after doing this, I let that, then I'll say from here, I can multiply this by 10 just to move it 1 unit, since the number which is repeating is 4 which is repeating. So it's 4, 4, 4 repeating. So I can multiply it by 10 both sides. So multiply this 10x, this x I mean by 10, I have 10x. Multiply this side here by 10. So my decimal point to move once, then I'll just have, so when it moves there, what am I going to have? When it moves this, observe from here, you just have 4 point, then the 4's continue. So you have 4.4 with the what? With the bar there. It's going to continue. Then okay, from here, what next can I do? I can subtract, say 100 or 10, I mean 10 minus x. Then I subtract the 4.4 bar minus 0.4 bar. So you see the 4.4 bar here, then I'm subtracting 0.4 bar. So this the recurring part here, because I'm subtracting, it's going to go and this gives me 0 here. Then what do I remaining? Here again I subtract, then this of course just gives me 0, like that. Okay, if we do that, gives me 4, I mean, gives me 4, since I'm subtracting nothing from there. Here when I subtract 9, so I have 10, then I have 10x, like this, then 10x, I am just removing one of the x's that is there. If I have 10 x's, I remove one of the x's, I remain with 9x. So this gives me 9x. This side I'll get 4. Then I can divide by that there. Then what am I going to have? So this here gives me x is equal to 4 over 9. Now I check, can I reduce this fraction further on? Do they have any common factors? Check. Okay, they do not have. So meaning this here is the final answer. So I've expressed it in the form a over b. So there's a and b there. Then this one here, we see 9 is not equal to 0. And a and b are what? Are relatively prime. They do not have any common factors. So in short, this is where you would finish from if all those are satisfied. Okay, let's try the next one. So for my next one, I have 7.26. So now what do I do? The bar there. So with this one, I make sure first I move this decimal point. So to move the decimal point, I have to multiply by 10. So when I multiply this by 10, I'll just have, so first of all, I let my x be equal to this. So I let it to be equal to this. Then I want to make sure that this decimal point is just before the part which is recurring. So I multiply by 10. So when I multiply this side by 10, I'll get 10x. This other side by 10, I'll get 2.6 with the bar. So this is what I'll get. Now I want to move this such that when I move it, in this case, since 6 is the only part which is recurring, it's only one value or one number, then when I move it like that once, so that in short is 2.6666 like that, going up to infinity. So I want to just move it once like that, such that this remaining part, when I come to subtracting, it will subtract the recurring part to move. So for me to move it once, I have to multiply it by what? By 100. So I will multiply this side and the other side also by 100. I mean by 10, since I'm only moving once. So when I multiply this side by 10, I'll get 100x. It's like I'm ahead of myself, 100x. Then the other side, I'll just get 726.6 bar like that. Okay, so now I need to get this one where it's just right before the recurring part, and this one where it's just right before the recurring part. Then I subtract these two. So I have to say 100x minus 10x like this. then this here should be equal to 726.6 bar minus 72.6 bar. So this 6 bar part is going to what? To cancel out automatically, gives us 0, because they're all what? They all subtract these 6's. Then I'll now remain with the, so that's 726. So I subtracting 72 from it, like that. So now what do I get when I subtract? So I have 726 minus 72. Then this here is going to give me 60. This here, when I just subtract, I know this here just gives me 4. There 6, 1 here. This here is going to give me 5. Then that's going to give me 6. So on the other side, when I subtract, I have 100. Subtracting from my 100 x's, I just remove 10 of my x's. How many x's do I remain with? 90 x's. Then this other side, I have 6, 5, 4. Then I can divide by 90 both sides, 90 this side. Okay. So now from here, I have to reduce this. So when I reduce, what am I going to get? Okay. Those that are following, what fraction? What does this give us? So I have x here. Yes, let's simplify this. I know first of all that 2 can divide into both of them. When I divide 2 into 90, when I divide 2 into 90, I get 45. Then on top there, when I divide 54 divided by 2, this gives me 327. So now, what do I get from there? Can I simplify that further on? Can I simplify it further on? Okay. So I can check, I can simplify this further on. Let me divide by 3, both in the numerator and in the denominator. And I divide by 3, I'm going to get 109 on top. Then down there, I'm going to get, so that's 45 divided by 3 gives me 15. So I get this here. So the question is, can I reduce this further on? Has anybody managed to reduce this further on? Really, it's going to end here. Can I reduce this further on? I check, can I reduce this further on? So, no, I cannot reduce this what further on. So this means that this here is going to be the final answer for this one. And you can check really and verify afterwards with the answer to your calculator. Yeah, though in your test, I know you won't use a calculator, but when you punch it, you get that this here, when you punch this, it's just going to give you this here. All right. So when the video or the link, when this video cuts, just rejoin using the same link. So we do this one, we have 4.23, then we have 5, 6 bar. So the 5, 6 here is the one with the bar. So we let your variable, let's say a, be equal to this. Then now I need to move this decimal point just before the recurring part, and I know it will have to move 2 times for it to be there. So I multiply 100. So I multiply 100 this side, so I have 100a. Then I multiply 100 the other side, I have 423.56, and your bar goes there. Okay, from here, what am I going to do? I want to multiply or make sure that this decimal point moves such that it goes here. Then I have the recurring part such that they'll be able to subtract as we were doing before. So this means this time I will have to move it how many times? 2 times. So I have to multiply by 2, by 100 I mean. So I multiply this side 100 by what? I multiply 100 by 100, which just gives me, this gives me 10,000 here. So I have 10,000 A, and on this other side, I'm just going to have 4, 2, 3, 5, 6. Then I have 0.56. So the 56 here is what is repeating. Then I can subtract these two such that this part with the bar and this one can go. So I have 10,000 A minus 100A. So you subtract that 10,000 minus 100A. I just get this here is going to give me 990A. Then this is going to be equal to, what do I do here? I have 4, 2, 3, 5, 6.56 bar. Then I have minus 4, 2, 3.56 bar. Okay, from here I can check that. Then just do 4, 2, 3, 5, 6, and the 3 comes here, 2 and 4. So this side has already subtracted, gives me 0. Then here I can subtract. Here I'll get 3. 5 minus 2. 5 minus 2 gives me 3 as well. Then I have 3 minus 4. So I can borrow 1 from here, get 13. So that's 13 minus 4. What is 13 minus 4? It gives me a 9. So it gives me 9 here. Then I have 1. Then I have 4 there. So this is what I get. So now this here is going to be equal to 41933. Then I can divide by 900. I mean 9,000 and 9,900. Even this side 9 like that. Then what does this give me my A to be? So this means that my A is going to be equal to, so 41933 over 9900. So now what is that going to give me? 41. Can I simplify that? Those that are ahead of me, have you simplified that? Are you able to simplify that one? Are you able to simplify that one? Okay. I don't think you are able to simplify this one. Yeah, where they are common, where you're able to reduce this. So, because that we are not able to do that, we then conclude that this just ends here to be our answer. So that's going to be our answer, like that. Yeah, unless there are any questions, but this is how you solve this part of the question. Anybody with any question? All right, since there's no question, move on. So actually the same concept that we're just from looking at. So what am I going to do? So here you have 0.4 with a bar there, then plus 0.134 with a bar. So I'll do this one, then I'll expect you guys to be able to do the rest, because these are actually not hard, because it's just from what we're just from learning to do. So here what you do is you make this side into a fraction, just that you're able to easily see it. So make it into a fraction. So when you say let 0.45 bar, this should be my x. Can multiply the bar, I mean the side just to x should be before the recurring part. So I get 4.5 bar like this. Then I can multiply it once, such that I have 10x. Then this will give me 45 point bar like that. Then I can subtract them, 100x minus 90x, and this is going to be 45.5 like that, minus 4.5 bar. So what is that going to give me? So the part with a bar here, can just subtract, then I have 45 minus 4, just gives me 41. Then this here gives me my 100 x's. I just remove 10 of them, I get 90 x's that are going to remain. Then I divide by 90, divide by 90. So I check, do these have any common factors here, 41 and 90. I doubt if there are any, but yeah. So since there's none, so meaning our fraction will end there to say that is just 41. I will write it here, 41 over 90. So it's key that we just write it there. Then we do the same for the other part. So this one is kind of bit involving. So we do the same. We let your x be equal to 0.134. Then the bar is there. Then this means your 10x, I guess you now know where that 10x is coming from, the 1.34 like that. Then you know that here multiplied by 100, so you have your 1000x here going to be equal to 134.34 bar. Then this here you can subtract 1000x minus 10x, and this here 134.34 minus the 1.34 bar. Then from here, this part with the bars subtracts, then just remain with, so 1000, my 1000 x's, I just remove 10 x's from there. I'll remain with 990 x's. Then from here, I see this part subtracts with that one. Then I remain with 1 minus that. Then I just get this is going to be 133. Then okay, meaning when I divide by 990 both sides, I have x to be equal to 133 divided by 990. So what am I going to do there? Okay, let me see what values can divide into both. Okay, is there any value? Those that are finding any value? All right, so now from here we check, can we reduce this? I think this does not have any common factor, unless anybody who's fine. From the top of my head, I'm not seeing any numbers that divide without leaving a remainder. So now these are the two parts, meaning that we have. So meaning we are adding plus 1, 3 over 9, 90 like that, 990. So can I then simplify this? Of course, I can now easily add the 2, because I know that I can just find my common denominator here first. So I have 990 like this. So the 90 dividing into this 990 gives me 11. So then the 11, I just say 11, you multiply by the 41 there, which gives you 1, 4, 1. Then you have plus this into there, divides in once, then you have 3 there, and this here is going to just give you, it's going to be equal to, so I add that the 150, the 140, 151 plus the 133, then this here gives me 584 divided by 990. Can I simplify this further on? Is a question I can ask. Yes, because they are now both even, and intuitively you're able to just divide by what? By 2 first of all. So on top, when you divide by 2, you get this as 292. Then down there, divide by 2, you get 495. 495. So can we reduce this further on? I think. Can we reduce this further on without leaving a remainder? Let's check for values. Okay. So let's see. Can 290? That's 292. Can we divide 3 there? 3 cannot go there. What values can go into both now? Okay. I'm not finding any values that can go into both. 4. Can 4 go into this one down here? Let's try 995 divided by 4. No, it leaves a remainder. So yeah, I think from here it would have ended. Yeah, so you have 292 then divided by 495. So this is going to be your answer for the first part. So now you follow the same procedure that we're doing. These you can only solve them. You make this first into what? Into a fraction in the form a over b. Even the other side, then now that's when you carry out this arithmetic operation in between. So that's how we do it. Maybe we do yeah, I'm sure you'll be able to do the others. Maybe let's do this last part, 5, which maybe has complications. So if you try those others that are worth it, remember you are free to inbox me and just send your findings. So you have this first part here. So you have to do the same. You have 6.27. How can I write this as a fraction? Anybody? So agree with me that this is just a fraction. If I multiply this by 100, I have 627. So I can divide this by 100 like this. So meaning 627 divided by 100 gives me that there. Yeah. Then I do the same for this one. I have 0.5. So what is 0.5? 0.5, if I'm multiplying this by half, I know I just get, by 10, this gives me 5. 5 over 10 just gives me a half. So this simplifies to half. So meaning the first part of it, we're just multiplying this 627 over 100 by half. So this is what we're doing as the first operation. Then divided by what follows now. So you can check what follows. We have again the 0.5. So here we put it like this in brackets. Then 0.5. The 0.5 is half. Then we are multiplying by what is 0.7. That's what 0.75. Okay, so that is going to simplify to 75 over what? 75 over 100. So now we have 75 over 100. These do have common factors. So what's the common factor of 75 over 100? So 25 should be 25 can divide into both of them. Yeah, 25 can divide into both of them. So 3 on top, then down there can divide 4. So you just have this. Yeah, then you multiply. So multiply by, you have your 836. So your 836 multiplied by 100 here. Then from here, you then close. Yeah, this thing is long, right? So you close like this. So this is like the first part here, which is from here to here. Then there's a division sign, then we have this. So you have divided by then. So our dividing, what are we dividing now? Okay, maybe let's work on here what's on top, then we bring in the division part later since we're just division. Okay, so now for this one, after getting this, what do we do? Here, multiplying by half. So you have 27, and then if I multiply this by half, so I have 6 here, 627, then okay, this here, so this is by the 1, then by the 2 there I have 200 down. So this is like more of the first part, I can say. Then I'm dividing this by, let me work out what's in this bracket here. So what's in this bracket here? So in this bracket, or this sets, but it's a bracket here. So I multiply, I have half, so I have 3. So there I have 3 multiplied by 8. Then multiplied by 3, 8, and 8, 36 over 100. Like that. Then of course this is closing there, closing that side. Then from here, what do I do next? So I can work out this part here, inside here, that I can, this here, just even if the brackets were there or not there, I would still be multiplying. So now, since I am multiplying this, that's 836. 836 divided by, can I divide, okay, do that. Let's say 100. Can 3 go into 100 without leaving a remainder? No, it does leave some kind of remainder. Okay, can we say 8, that 836, I can divide it by 2, right? Such that, or let me try even 4. I can divide it by 4, yes. Such that here, I divide by this by 4, I have 2. Divide that by 4, I have 209. Then I can then multiply to say the 9 by the 206. I mean the 3 by the 206. 209, I mean. 209 by 3, which gives me 2, 7, like this. Then down here, I have 100, 200 now. So 2 by 100 gives me 200. Then it's out of the bracket. Then I'm just dividing this by this. Also, I can remove out of the bracket since it's just division like this. Okay, so this is what is on top now. This is what remains. And this here gives me 1, which is very nice. So on top, we just get 1. Then let's now work out what's down. So what did we get? So what are we going to get down? So down there, we have here, you can check this first part. We are saying, so there we have, so this is 0.25. So what is now what is 0.25? So if you multiply that by 100, you have 25 divided over 100. And this can go into there 1, you can simplify it as 1 over 4. Then multiplied by this other side. So the 101.1, this here is just the same as saying 1 over 10, right? So that's the same as saying 1 over 10. Yeah. So I can write my 1 over 10 here. Then multiplied by this other side gives me 3 over 4. Then I have this part with the bar. Okay. Which requires me to do some extra work. So I have to let my x be equal to 21.3 bar. The good thing is the full stop is just right before the recurring part. So I can just multiply by 10 here because it has to move once. Then I have 3.3 bar. Then this will be 10x minus x, and this will be 123.3 bar, then minus 21.3 bar. Okay, and from here, what will I get? I get 9x. From my 10x's, I just remove 1x. Then this here is that goes. Then I have my 213 minus 21. So when I subtract that, I just get 192. Then I can divide this by 9 and that by 9. And this here will just give me 190. So it will be x equal to 192 over 9. So now you ask yourself, is there any common divisor there, any common denominator? Okay, so 3 can actually go into into both of them. So 3 can divide into both. So here 3, this gives me 64. Then there 3 gives me 3. So I have 64 over 3. This, of course, cannot go any further. So I just have here 64 over 3. Okay. So after getting that now, then the outside there I'm multiplying by 0.5, which is just half, like this. So now I work out this, which very much I think have simplified my work. Yes. So what am I going to work with? I start with what I have in the brackets inside here and there. So 1 by 1 gives me 1. 4 by 10 gives me 40. Then here, meaning I can move it out of the bracket like that. Or if I keep it, I still know that I'm multiplying. Then here, this and that there divides. Then I can divide 64. 64 divided by 4 just gives me 16. So here 1 and there 16. And I'm going to get my value as 16 here multiplied by half. So this is what I get. So now here I can, this divides this one, here 1, there, going to give me 8. 8. So I have 1 over 40 multiplied by 8. And I know here 1, there, it's going to give me 5. So I have 1 over 5 that remains. So down there, I just remain with 1 over 5. So now I can simplify it. Remember, there's a division sign in between, which is this one here. So meaning I'm just dividing 1 divided by 1 over 5. And this here is just going to be 1. So this division sign changes to multiplication. Then I swap my here 5, then 1 goes to the bottom, and this is just going to be equal to 5. So that's your answer. All right, a lot of working, but then gives us a pretty good answer there, which is just 5. Unless there's anybody with a question on how we work out this, but that is how you do it. Okay. This here kind of get a bit, I don't know, it's a bit complicated, but we are okay. So has anybody tried this one such that where they had the problem, we just go direct, like, okay, there, that's where I had the problem. So they're telling you to express in the form a plus ib. This is the general form of a complex number. So how do you express this one? Okay, let's start with a. Can somebody pick out one question which we should do? Since there's A, B, and C. Because of time, let's pick out one question which we should do. Just unmute your mic and speak. Just pick out one of them. Anyone.
C.
Okay, C. So, C now, what am I going to do with C? So with C, I have 4 plus I, then I have root 3. Then plus negative 6 minus 2I, then root 3. This one is actually easy. So you group now. So I have to group these. I group the real part with the real part and the imaginary part with the imaginary part. So I have 4 here. Then I have this here, minus 6. Since here there's a positive sign in between, so you don't have to worry about that. I can rearrange this. Then I have plus I root 3 like this. Then minus 2 here root 3. Of course, there's an I there. Okay. But this that here just gives me negative 2. Then this here, this is the same as saying 1. Just saying 1 minus your 2 there. This gives you negative 1. So this here gives us negative I root 3. This is what you do. So for the coefficients in front, just subtract them normally. Keep your I if it's going to still be there, and of course your root 3. And that's how you do it. You simplified it. Your A is this one. Your B is here. So that's how you do this one. Okay. let's go to this part. Okay. Which other one can we do? I thought they were in parts. Let's go. Let's pick out two last. I don't know if it's two last questions. Yes, which we can try. Then we call it a day. Anyone? Feel free, please. Anyone, please, guys. Just pick out a question. You might find it's the one which is coming tomorrow. So if you're not clear on one of them, just speak out. Then we do it. Okay. So in case everybody is clear, there's no question. We call it here. Do I have any question? Okay. Looks like people do not have. I'll pick out this one. It looks a bit random, but I'll just pick out this one to kind of explain what you do for a fraction case. The fraction case would have this minus 3i. Okay, for the others, and you know that when you're multiplying, if you have I squared, this is just equal to -1. Okay, so now for such a case, what you do is you multiply, you rationalize this by multiplying by its conjugate, which will be 2 plus 3i, and there 2 plus 3i. Then when you multiply this by its conjugate, so on top what I get in 4 by 2 gives you 8, 4 by 3 gives you 12i. Then there 7i by 2 is going to give you, that will be plus 14i. Then 7 by 3 gives you 21. Then you have 21i squared. So this will be 21i squared there. So you do the same for the down part, and you just have 4 there. Here when you multiply 3 by that one, that's 2 by that one gives you 6i. There gives you -6i. Then you multiply that one there, just gives you a -9i squared. Okay, then wherever you see an I squared, replace with -1, then you can add the like terms. So this and that I can add the 14 and the 12. Did we do this right? Okay, yes. 14 and the 12. So 14 plus 12, that gives me 26. So I'll have 8, then plus 26. Then where there is, then where there is I squared, so there's 21, that will be plus 21. I squared, I put a -1. Down there, I have 4, then minus 9, where there's I squared, -1. Then here, this simplifies to, so I have 8, this will be -21 plus 26i. Then down there, you have 4 plus 9. Then you can continue there. Say this is just going to give you, okay, this just gives you, so 21, what is 21 minus 8? 8 minus 21 gives you -13. Then you have -13 plus 26i. Then down there, you're going to, so what's your 4 plus 9 gives you 13. So you have 13. Then you can divide 13 now. 13 into there gives you -1. 13 there gives you +2i. And this here is the form that you're looking for, where this part here is your A, and that part is the what? Is the B. Okay? So this is what you end, and that is how you do the others. Unless there any question, but we end here for today. All the best, you guys, in your quiz. So we will revise the quiz after you write, or if you have said yes. Yes, I can get you. Go on. Yes, you can go on.
Is it possible for you to do D?
To do D. Okay, this one here.
Yeah.
All right. So okay, let's do that one. So you can mute your mic for now. Then yeah. So D we have 5/8 plus 1/2i like this. Then minus you have 7/8. Then plus 1/5i. So what you do is you multiply this negative there. So this here you can remove out of the brackets. Then you have 5/8 plus 1/2i multiplied by the negative. There you get negative 7/8. There you get negative 1/5i. So now I group the like terms here. So when I group the like terms, I can group the numbers where I just have 5/8 here. This will be minus 7/8. Then I have plus 1/2i. Then I have minus 1/5i. Okay, what is this going to give me? Since these have the same base, I can just add what I have in the numerator and keep the base. So that is just going to give me negative 2/8. Then for the other one, I have to get the common denominator. So what's the common denominator? Common denominator of 2 and 5 is 10. Then that 2 divided into 10 gives me 5. Then I'll just have, that will be 5i on top. Then I divide the other one, will be 2, and that will be minus 2i like this. Here I can divide, and I'll say that will be negative 1 over, so that will be 4. Since 2, 1 here, there, 4. Then this one here, when I subtract, I get that will be, this will be plus. Then here, when I get, that will be 3i. Then this will be over 10. So I have worked out this. Then I can write it even as negative 1/4 plus 3/10. And I write my I like that. So A, B. So A, B there. Okay, so this is how you work out this one. Is there any other questions?
I would say that can you do M?
Can I do M? Somebody said we do at M, this one? Okay, I didn't get that clearly. She said M or do A. Okay, wait for you to kindly repeat M or A, but I think it's M. Okay, so let's do M. So M.
M.
Okay, M. So M, you have 1 plus 2i over 1 minus I. So you get it in parts. Solve this, then you solve the other one, then you add them. This is the plus sign. So what you do, multiply by the conjugate in the numerator and in the denominator. So you have 1, there you multiply 5. So the conjugate just changes the sign there. Then you get that. Then what are you going to get on top? You get that will be 1 plus I. Then that will be plus 2i. Then that there is going to be plus 2i squared. Then down there is going to give you 1 minus what? I squared. Okay. So the easiest way, again here, when you have a conjugate, you can just square. You say, since I have 1 and what, you can just square the 1 squared. Keep your negative sign in between, then you square the I squared part. So you can always do that to easily or get it faster. So that gives you 1 plus, that will be 3i. Here where there is negative I squared, I can replace, where there's I squared, I can replace with negative 1. Then I'll get that to be negative 2. Then down there, I'll have 1, the I squared, I can replace, I get negative 1 like that. And this is going to be, I can add this part to that, then I get that to be negative 1 plus 3i. Then here, this will be divided by negative by negative gives me positive, then I have 1 plus 1 gives me 2. So this simplifies to, so that just simplifies to negative 1 plus 3i over what? Over 2. So I would want to keep it like this. Let me write it here. I can simplify it, but or I can write it in another form, but I want to keep it like that for now, such that I see what I'll get on the other one. So on the other one, I'll let me get try to get the same. So you have 1 minus 2i. Then you have 1 plus 3i, which is this part here now, the second part here. So from there, multiply 1 minus 3i, then multiply 1 minus 3i there. So on top, you're going to get that will be 1, then you get negative 3i, then minus 2i, then you have this negative by negative gives you plus 6i squared. Then there you get, so you square I squared minus 3i squared, like this. And what do I get? So you get here, what is I squared? You place negative, you get negative 6. Then it will be 1 minus 6. Then you have there where you can add these two. So when you add the 2, you get negative 5i. Here you get, of course, when you add this, you see that you get negative 5 as well. So here this will give you negative 5. Then down there, you have 1. Then 1 squared is 1. Minus, here you square this, you have 9. I squared is just negative 1. So multiplied by negative 1 like that. Then here, this is going to give you negative 9. Negative 9 by that, you get 1 plus 9, which gives you 10. So down there, you just end up with 10. Then now, you can simplify this. So how can you simplify this? You can simplify this, you say divide by, so 10 into there, so you have 5 divided by 10, negative 5i divided by 10. So this gives you negative 1 over 2, there also negative 1 over 2 and the I. But then I can write that since they have the same denominator, I can keep the denominator and just say that's negative I minus what? I, like this. So after getting this, now I can combine the two. How am I going to combine the two? See, they have the denominators are the same. So I have negative 1 here, the first one which I found, plus 3i divided by 2. Then plus, since it's a plus sign, negative 1 minus I, then here 2. Okay, from here now, what am I going to do? They have the same denominator, so I keep the base, then I can just work out what is there. So negative 1 there, it will give me negative 2. Here 3i minus this negative I is going to give me plus 2i, I mean. Yeah. Then you can divide 2 into both of them, and that just gives you negative 1 plus I. So this simplifies to negative I plus 1. Okay, unless there is any question, but this is how you work around this. Okay, no question, so we end here for today. All the best, guys, in the test. Quiz tomorrow. Is that a question?
Yeah, question. Can you solve for question F?
Okay, question F is not really 3. Okay. Question F. This is going to be the last one we do because so question F is easy, guys. Just what that means. And I'll just explain. I won't really solve this one. I would want you to solve it. This is the same as negative 2 plus 5i, then like that, negative 2 plus 5i. So you multiply this. Just multiply. Where there's I squared, you put -1, then you simplify. That's all. Anywhere else you want clarity on what to do? Okay, there's nothing. So remember to subscribe to the channel. Remember to follow the link in order to register for the lessons, and you're able to have access to our website where all full videos are posted for these tutorials. So be able to access through that. And those registered, you have free consultation at any time you want. You can inbox me and I'll be able to help you. All right, if there's no questions, we end here.